Hey guys, recording the vodcast for homework 3.4 and working in a little bit of a different order here. So again, this is homework 3.4. This was the assignment for Friday night. Question A says the gas N2O4 decomposes to form NO2 according to the reaction below. So here's N2O4, and it actually decomposes to produce two of these NO2s. First off, notice that free radical right there. That is a bad thing. So we know that this side of the reaction is not a good side. This is the better side, and that's going to become important a little bit later. For the first question, it says predict the delta H for the reaction. All right, so there's many ways to go about doing this, but let's just fall on the information that we know so far. Okay, we know that delta H equals sum of broken minus sum of formed. And in this reaction, there is only bonds broken. Nothing is formed on the right side. So there is nothing formed. If only bonds are broken, delta H's only option is to be greater than 0. Bonds are only formed. So only formed, no broken bonds. Okay, so delta H in this case is going to be positive. Predict the sign on delta S. Okay, so I look up here and it doesn't give me information about the states of matter. When I look at this reaction, I have one thing over here and I have two things over here. So the reaction still did get messy. So delta S is going to be positive, and that's because you have one reactant and two products. Okay, it was messy. So if you don't have gases and liquids and solids all over the place, just look at the number of reactants versus the number of products. Think about this as a piece of paper kind of tearing in half. So the piece of paper tears in half, and you have the two pieces of paper left. This side is definitely cleaner. This side is messier. Okay, so this is the piece of paper was torn in half. It was messy. So delta H is positive, delta S is positive. Going to this next one, it says on the diagrams below, which one best represents the relationship between delta G and temperature? Okay, so although this looks fancy, they're just looking for the spontaneity conditions. Okay, so let's go to our chart that we have glued into our notes. Okay, so on your chart, okay, this is the one that's glued in your notes. Okay, if delta H is positive, which it is up here, and delta S is positive, which it is right here, what's up with delta G and temperature? So if this is the case, what it should say is it's spontaneous at high temperatures. So we're looking for the graph here that shows spontaneity at high temperatures, and that's going to be this graph. Okay, remember that being spontaneous means a decrease in delta G. When delta G becomes more negative, the reaction becomes more spontaneous. So as temperature increases in this graph, delta G decreases, and that is consistent with this, spontaneous at high temperatures. Okay guys, have a great day.